Hello, ladies and gentlemen, and welcome back. We're on the very last question, question 25 of the 2008 Pascal paper. In the diagram, triangle PQR is right-angled at P. Well, they haven't shown me that, but okay. And has PQ is 2, PR is 2 root 3, altitude PL intersects median RM, so median means these are midpoints there. So PL is an altitude, so it's the height of this triangle, and intersect at F. What is the length of PF? All right, there's a lot going on there, and there's a lot of information, and F seems to be... I feel like it's going to take a little while to get F. Now, if you know a little bit about right-angle triangles, or a little bit about trigonometry, and yes, I know you're not supposed to know trigonometry in grade 9, at least not when this contest was written, that was a grade 10 sort of thing, you can actually recognize a fairly common right-angle triangle. It's not a Pythagorean triple, because the side lengths are not all, they're not all integers. 2 of them are. We'll draw them a little bigger. But it's a fairly common triangle. I don't know if I'll need to use the properties here. I suspect I probably won't. But if you have a side length of, say, 1, you can get a hypotenuse of 2, and the other side length is root 3. That's just basic Pythagorean theorem. But the angles here are 30 and 60, and of course 90 degrees. And this is what we call a 30, 60, 90 triangle. And I can already see that right here. PQR is just this 30, 60, 90 triangle, and all the sides are multiplied by 2. So if I know that, I can tell you right away PQ is 4. I don't have to do any Pythagorean theorem stuff. I just double the length 2 down here. Now, as I just said, I'm not going to try and use that information. But I think it might be helpful if you could recognize that. So knowing little extra things like that can help you do things like 23, 24, 25 a little faster on some contests. That doesn't mean that you should feel obligated to learn more advanced math before doing these contests. I'm just saying if you pick these sorts of things up, maybe you go to an enrichment program, maybe you watch videos on YouTube and pick up things, whatever you want. But sometimes that sort of thing can be helpful. Okay, but let's try and do the question just normally. Alright, we'll draw our picture. I'm going to draw it fairly big because I have a feeling I will be mucking it up with some marks. Now, something that catches my eye is the right angles. They sort of hide the right angle at P, but they do mention it. And then PL is also a right angle. And so I'm thinking that there could be some similar triangles. And RM, we'll say, comes down here. Now, if the side lengths are 2, the median splits these into 1s. And so we've got that. We've got 2 root 3 over here. And, all right, well, let's think about this for our right angle triangles for a moment. I've got this angle here and some right angles. So I think we can observe that triangle PQR is similar to, and you got to make sure you get the angle right. It'll be, so it goes from the right angle to Q, so we'll go L, Q, P. And if we have these similar triangles, then we can say things like PQ over LQ is the same as, and see the nice thing about this one is it has PQ in both places, is the same as QR over QP, which is just PQ. So we've got PQ down here. So that tells me PQ squared will be LQ times QR. QR, I guess we can get that right away from the Pythagorean theorem. I didn't actually do that yet. So QR squared is PQ squared plus PR squared, but that's 2 squared plus 2 root 3 squared. And that's 4 plus 12, 16. And as I predicted a little while ago, square root, we get 4. So PQ squared, which is 4, is LQ times 4 as well. That tells me LQ is going to be equal to 1. Oh, and we also have MQ as 1. Interesting. So if Q were the center of a circle, L and M would be on them. And PL would be tangent to that. I don't think we'll need circle geometry for this one. I think this is going to be some similar triangle stuff. And it also just sort of strikes me as interesting that they said altitude PL. It's, I mean, they could have just said L lies on QR so that PL is right angled. That's certainly possible. And it doesn't mean anything necessarily that they wrote altitude, but makes me think of, 1/2 base times height and areas. So maybe we'll experiment with some areas in a little bit. But I'm not entirely sure I'm done with right angles and more similar triangles, or I guess I can figure out by Pythagoras, by the Pythagorean theorem, I can figure out MR, and that might be in some way useful. So LQ is 1. Has that really got me anything? Has that really accomplished anything? Well, I know a little bit more about the triangle, but we're still trying to figure out PF. Is there a plan of attack we could use? So how might we get PF? Okay. Well, it's triangles, and I did just mention area a little while ago, so it's entirely possible we can get some sort of area for PMF. We know its base is 1, and then, well, no, that would just get me something involving F. I doubt very much that FMP is a right, or MFP is a right angle. So I don't think we'll figure it out with areas. And if we're going to do lengths, well, PF isn't really a very interesting length. It is PL minus FL. So, I mean, there's that observation. PF is PL minus FL. So if I can figure out PL and FL, and I think I can figure out PL, because it's an altitude, and I know RQ. So, just flip the page here for a second. What do we have? We'll draw. I'm gonna drop the median for a moment. I know I haven't actually used that yet, so I do need to use the median information, I would suspect. But we've got L here. 4 is this length, 2 root 3 here, and 2 here. But this is the exact same triangle. If I just sort of lay it on its side, we have a height here of PL and a base here of 4. So the area is going to have to be the same for both of them. Area is 1/2, base is 2 over here, times height 2 root 3 because of the right angle. But it's also going to have to be 1/2 base of 4 times PL. Okay, and it just occurred to me I could have just figured out PL from the Pythagorean theorem, because I know LQ is 1 and PQ is 2. So it looks like there's sort of lots of ways I can go about this question. Anyway, get rid of the 1/2. 2 times 2 is 4, so divide by 4. So PL is going to have to be root 3. So now the question then becomes, can I figure out what FL is? Okay. Well, until some inspiration strikes, I'm going to go to my bigger picture. It's root 3 minus something. Does that... Are any of the actual answers root 3 minus something? No, but they do all have root 3s in them. And are any of them... Yeah, they're all fractions of root 3, so they're all definitely less than root 3. So, for example, if I knew that FL was 3/7 root 3, I'd be looking at C here. So, fractions of root 3. Is there a way to do some more similar triangles? A similar triangle involving FL. Well, we've got a right angle there. But the problem is... this angle up here and this angle here aren't really helpful, and I don't have another triangle involving just FL. Unless I were to connect F up to Q. But I don't see how that would help me. Could I make one? Would there be a good place to have... What if we drop a perpendicular for M here? And call this, I don't know, MN. MN would be an altitude of RMQ. I know the base, so then I would know the height. This would also be similar to PQL, again. In fact, it's the hypotenuse is the same. It would go down to 1/2, so what's... we know that PL is root 3, so this would, I guess, be root 3 over 2. Now, that doesn't mean FL is root 3 over 2. In fact, it suggests that FL is less than root 3 over 2. And, by the way, for people wondering, how did you figure that out? M and Q is similar to PLQ. And then I did some ratio work like I did up here, just in my head. Okay, so that's a little promising, I guess, but how would that... So we would need to then say RMN is similar to RFL. But I can't establish exactly what the ratio would be. I need a bit more information. Oh, okay. Let me draw a new copy of this picture. I want to hold. I'm gonna make this a little more centered as well. By the way, I want to hold on to my thought because I thought it's a good thought. So I've got PL here. Median comes down here. I have used the fact that it's a median because I've got 1 here. These guys are similar triangles. By definition, I'm putting N down here so that this becomes an altitude. Fine. This guy was called Q. This is R. This is P. We can see that triangle RNM is similar to RLF. They both have right angles, and they both have this angle up here at R in common. Fine. So that tells me FL is to MN as... Oh, what was my thought? It was RL is to RN. Okay. But RL is RQ minus LQ, and RN is RQ minus NQ. Now, I know RQ is 4, I know LQ is 1, we have 4 minus, and because the ratio here is 2 for the PQ to 1 for the MQ, and the fact that LQ is 1 makes NQ a half. Okay, so we get 3 over 3 halves, which is 7 halves. So that becomes 6 out of 7. Okay. But that's then FL over MN, and I know MN is root 3 over 2. So FL is 6/7 MN, which is root 3 over 2. Cancel out some of these 2's, and I get... Oh, I do get 3/7. Honestly, I just picked C out of the dark when I was talking about that earlier, but I do get 3/7. Cool. I like it when that works out, although it kind of looks like I'm rehearsing these things when that happens serendipitously to me, and I genuinely don't. for anyone wondering, I just sit down. It's the Pascal. I could see somebody accusing me of that for the Euclid or like a Putnam paper or something, because those can be hard. But a Pascal, no, I just sit down and do these, and when that happens, it's quite coincidental, and I like it. But if that's 3/7 root 3, and we know the whole thing is the whole of PL is root 3, then that tells me this must be 4/7 root 3, because 4/7 and 3/7 makes up 1. So that tells me PF is 4/7 root 3, and that is, in fact, C. And so C is what we're going to bubble in. And we are done the whole contest. Okay. So, that's question 25, and that wraps up the 2008 Pascal paper. If you're looking for more Pascals, I do have older ones already uploaded. If you're looking for more challenging multiple choice contests, I'll be doing the Cayley, which is the next grade up, Cayley 2008, in a little while. If you're looking for same difficulty level but not multiple choice, maybe a written contest, the 2008 Friar will be coming up. That'll be the next video, or next set of videos I upload. And so you can practice your written solution skills and how we go thinking through questions with multiple parts and how they're connected. And yeah, I leave the choice up to you. Thank you guys so much for watching as always, and I will see you in whatever math video of mine you next choose to grace with your presence. Have a wonderful day.